Here I solve 26 and 27. Okay, so 26 is stupid that v1 is just 1 minus 1, and ask you about which one is orthogonal. So find v2 such that v1 and v2 inner products or dot product 0. So the answer is obviously C, right? C, because C is 1, 0, 1. So when you do the inner product, you have 1 times 1 is 1, plus 1 times 0 plus minus 1 times 1. So it's 1 minus 1 is 0. So the answer is C. So 26, the answer is C. This is simple, so yeah, so that's it. Okay, so 27, if the curve in a YZ plane, basically somehow you plot some diagram, and curve in a YZ plane with the equation f of y, and rotate around the y-axis, so rotate. So you will have some surface, which is, I hope my okay, it looks some surface, okay, and which of the resulting surface equation. Let's just test about your geometry, your geometry thinking. Okay. So okay. So if I take this point, then the length from 0, 0, 0 to this is just the f of z. Not basically f of y, right? The distance, and this distance is composite with 2 coordinates. One is definitely this x, right? One is the z, right? So basically, how should I plot it? This is x, this is z, right? So basically, you have the x and z, and this is the rotation point, f of y. Right, there's a triangle here. Probably my plot is very bad, but you know what I'm talking about, right? You need to use some imagination. Okay. So this tells you that the Pythagorean principle that the f of y squared basically is x squared plus z squared. So the answer is A. The answer is A. That's it. So you can let me see. Okay, so B is not correct. The C is, I mean, it's obvious that the E should be correct. The A should be correct. I mean, if you don't understand how to solve it, you can think about some examples. Maybe the sphere or something, right? So when you do sphere rotation, then the result should be a sphere. So each turn should be quadratic. So from this point of view, the A is the natural choice that we should choose. Yeah, that's it.